Hello, welcome back to the channel. This is Kasra. If this is your first time here, I'm a machine tool designer and builder by trade, and at the moment I'm working on a DIY project in my own garage, as you can tell. This is a super precision 5-axis milling and turning machine, and in today's video I want to do things a little bit differently than what I used to show you guys. So I usually record videos when there's been a milestone in the project, and I will bring you up to date with what's been happening and installed on the actual machine. But because I've seen some people requesting how I actually put these bits together, I want to try things a little bit differently this time. So what I will do is record the whole process of assembling some of the bits that go onto the A axis, or the B axis rather, the main swiveling axis. And then if you've got any questions, comment them down below. Please don't judge this video in terms of quality, because this is the first time I'm trying this new format, so I hope it goes well. I probably will set up a time-lapse camera as well somewhere in the corner. So we'll play it by the ear and see what happens. So without further ado, I will reposition the cameras and everything, and let's have a look at what we've got to do today. This is the B axis of the machine, so it's the swivel axis. We will have a bearing here, and this is the main bearing. There's a secondary bearing at the other end, but we will be focusing on installing this one today. This diameter and this bottom face where the bearing would sit, they have been jig round, and the diameter of this ID that's been jig round is about 2 microns below the diameter of the bearing. That means we need to warm this up and cool the bearing down, and then just put it in place. I don't know why I want to do this on camera, because you only get one shot at this. If you mess it up, then it's going to be a very expensive disaster. So I hope it will not happen. I have cleaned the parts. I'm going to do a final wipe before we will proceed, and then we start warming it up. I did some calculations yesterday, and I think if we warm this up to something around 60 degrees and then cool the bearing down to -10, 15, then we will have a 0.1 millimeter of clearance, maybe a little bit bigger, maybe sort of 1500, something like that. So in theory it should go inside very easily, like a glove. I've got a temperature laser gun here, which we will use to test the temperature. Before we start, the temperature in that corner is about 14 degrees C. The surface is about 16 degrees. I guess that's because of the alcohol evaporating. So yeah, this is about 16 degrees, and then that corner is about 14 degrees. So we want to bring that to something around 60 odd degrees, and then the bearing is already in the freezer, it's been cleaned. So then we will bring the bearing here, and then we will start with the mounting. Okay, I'll touch the side, unfortunately. Right, here goes nothing. There we go, like a glove. There we go. I will bring my trusty Loctite here. So it's a a medium strength thread locker, and we will continue with tightening these bolts. Trusty Wera Zyklop, I think that's the right pronunciation of this. I love this thing. There's so many negative comments in YouTube about this stuff, but this is amazing. I mean, the way that this works and the action, and it's just great. It's amazing German engineering. And I've got these Wera tools as well, these Wera Allen keys, and they've got these little ball bearings, and they are spring loaded as well. These are amazing stuff. I mean, that's for holding the bolt in place. So you just put it there, doop, clicks, and it's not going anywhere. It's not magnetic, it's actually mechanically linked, and it's got just the right amount of tension. So it's not going to lose the bolt, but as soon as you pull it out, boop, it comes out. And then they've got a profile, a special profile of this hex key that supposedly it's not going to ruin the head of the bolt, and it's not going to round it, but I don't know. By the way, these are M5 20mm bolts, and for this specific application, anywhere that is a lot more tension and torque and more stress, I go with either a 10.9 or a 12.9, and these are 12.9 grade bolts. So the bearing for the B-axis now done. Now the next job is to put the stator of the motor here, and before doing that I need to put the copper coil for the coolant, and this will go in there. Give it a try. Okay. Now the trouble is, I don't know if now the coil is not now preventing it from sitting, or if it is a bit tilted. If it is tilted, it's not going to sit properly. But if it's also some coiling in the way, it's not going to sit either. Yes. Yes. Success.
A great success!
Okay, I'm just gonna hammer it down a little bit, just a tiny bit. Just to make sure it is seated properly. Where is my... Now, what we need to do is to put a seal around this, feed a 4mm tube down there, and then we can start pouring our thermal compound. So, but I think I'm gonna need a break. I've been at this for at least 3.5 4 hours, so I'm just going to give it a pause, go have a bite to eat, and then I'll come back and we can carry on. Before we proceed to the next part, we need to put the O-ring around here. Now this O-ring is to create a seal between this face, between these two pieces, so that we can feed thermal paste in between. So I'm just going to shove this So this is about 1 millimeter thicker, and this stuff is, I think it's called nitride rubber, which is what O-rings are made from, really, most of them, or gaskets. So let's see what we can use to shove this down. You can see a hole there that's been tapped, that one. So that hole, it's an inlet for the vacuum tube. So I've got a vacuum pump here that will be sucking the air out, and then from this side, you can see it from here, we will feed the tube in, and then we will fill the whole cavity with that material, which is the thermal adhesive, and hopefully we can fill the whole area between the stator and the body, and in between all of those all of that coil with loads of thermal paste, so we would have a much better thermal conductivity between the copper coil and the stator. Right, so this is the tube that I have for feeding the thermal paste, and now I've got my my glue gun here, and now I have to create an airtight seal, which is going to be a bit tricky. So here goes nothing. Okay, it's now the next day. So after multiple attempts to get a good seal around this whole assembly, I ended up using a lot of duct tape from on the top and underneath, and then using some pieces of sort of 3mm fiber wood to get a good seal around it, and loads of this thermal type of glue with one of these glue guns. So I now have managed to get a good seal around this. This is our thermal compound, which is a type of grease, and it's a silicone fluid, and it's like grease, so it's not going to harden. I do have another version of them, which is type of a gluey compound, but I don't need that anymore, because I used the rubber seal, which I showed you previously. So this is going to get injected from this 4mm tube, and then from the top we are this is connected to the vacuum pump, and then I've got the gauge here to read the amount of vacuum that's happening. So if I it's actually not a great seal, and I don't really want it to be a fantastic seal, because if it is if it starts vacuuming too much, then it can just like destroy the whole thing. So I'm not going to I don't need a lot of vacuum power. As long as it's only sucking and removing most of the air out, it's plenty for what I want to do. So I'm just going to demonstrate the amount of vacuum that it does. This particular gauge goes to negative 0.9 with this vacuum pump that I have, so it's pretty good results. So I'm just going to turn this on and then just going to squeeze this tight, so it will get a good seal, and you can have a look at it. So this is now going to vacuum a little bit, and this is more than enough for what I want to do. Okay, so it's about a week later, and I'm still fiddling with this project. It's proven to be much harder than what I thought it would be. So it's the main issue is to get a good seal around the whole thing. Now I've put the B-axis housing on top of a small granite plate that I have, like a surface plate, which has got a very good flatness, and because underneath the bottom face of this housing is also lapped, it should give me a good seal, or that was what I thought it would. Anyway, I've tried multiple ways of sealing this. Now there's loads and loads of different layers of glue, including thermal glue, including various types of sort of tapes and things like that, like duct tape, and then there is a clear tape and some plastics, and as you can see, there's some cling film on here as well. Now I've figured out that the diameter of this tube is quite small. This is a 2mm ID tube, so it's not the best one for this job. So I've pulled most of it out and left about 10-15 millimeters inside, but I still have the canal that I've made using the thermal glue. So hopefully when I inject the thermal paste inside now, it should fill the canal and then goes inside the cavity. Now that's the theory. I have not opened this. In theory it should work, and it should not go anywhere else, maybe a little bit here and there, but it should be going inside where it needs to be, between the stator and the housing, but I can't say for certain. I've decided to inject all of this thermal paste, silicone paste inside, and hope for the best. So because I don't want to sort of remove all of this, because I've got a relatively good seal. The vacuum goes down to negative 0.4, 0.5, which is yeah, kind of okay. It was a little bit better, but as soon as you move this around, some small leaks start to happen. It is sucking in, which is a good sign. but it is a very, very painful and slow process. So it takes about a couple of minutes to empty each of these. And I've got what I've done 2. Now I've got 1, 2, 3, 4, 5, 6 more of these left. So let me just do it one by one, and then we will open it up and reveal what's gone inside. Please keep your fingers crossed for me, because I don't know what's going to happen. So we shall see. It might be a very expensive experiment, because I'm going to then sort of left with loads and loads of these thermal pastes that are in the wrong place. So I hope it's not the case. I hope they go into where they need to go. And we will open it up together and reveal it. Okay, so it's been over 2 weeks now. Obviously I haven't been working on it constantly for 2 weeks, but I have now reached a place that I can share a little bit of update with you guys. So what I've done is I've managed to finalize the vacuum thing, get rid of all the excess stuff that you saw, and now the space that I had is now filled with that material, which is the thermal paste or thermal grease. I have not sealed this part off. I got rid of all of the thermal glue, so I removed all of that. That was kind of temporary. So I've got a gasket seal, a silicone gasket seal, which is quite good at withstanding high temperature around here, and I will be pouring that at some point, but for now this is a little bit open and a bit exposed, but nothing's going to get in there because it's now filled with that material. For assembling the main shaft, I've got the torque motor's rotor that goes over this, and then we'll bolt it down, and once we've done that, then we will proceed with mounting it inside the bearing, but there are complications to do that, so I will explain as we go forward. But now the next step would be to mount these onto the bearing. So these are couple of plates that I got them laser cut, and these are just tools to help me with guiding the shaft down there so that the whole pattern would be in the correct place. And also I can use the bolts to sort of pull the shaft into the bearing. So we will be mounting them now. So these have been laser cut, and then the holes have been drilled to size, and it's got about 6 mil there. So I'll just flip this over and we will start with putting these on the bearing. this is a very interesting part. So if you haven't watched the previous videos, I'll give you a brief introduction to this bit, this part. So this is the actual rotor, and in this space we will have the torque motor rotor, so all the magnets. This diameter is where it sits inside this bearing that you saw before. There will be a secondary bearing mounted here. Then this space is where the encoder ring will sit, or the encoder disc, and I've just roughened this up a little bit with some sandpaper to sort of help with the adhesive that I'm going to apply here, so it will stick to the material a little bit better. And then this diameter, this last one, is what is bringing the C axis into the center line of the B axis. So this diameter will go inside the B axis. There's a bore inside the B axis that will sit there, and then it will have like 3 different bolts to hold on to it. Now the way that we mount this, it's not extremely tight tolerance, so it's a relatively loose fit. I think it's about I don't know, maybe 20 to 30 micron difference between the two. So it's a relatively looser fit because it doesn't need to be a very accurate mount, especially for the B axis, because this is not a high RPM motor, so it's not going to have any unbalancing effect on the system. Now the Loctite that I'm going to use is this one, Loctite 609. So Loctite 609, I don't know which way you will be seeing this, probably this way. So Loctite 609. This is for mounting a bearing to either a shaft or a bearing housing to the bearing outer ring. They come in different strengths. This is sort of low to medium strength. It says actually medium in here, and it's got a thermal sort of range of up to 150 degrees. So if you want to get rid of it, you just need to heat the part up to 150 degrees, and then it will break or come loose. So this is the one that I'm going to be using both for this one and for the other bearing that I've got over there. So this is what the manufacturer actually of the motor suggested. So let's put this to the side. Now let's bring the rotor out. I'll probably start using these gloves from now on. Okay, so I want to give you a quick update on what's been happening. So I managed to put the shaft or the rotor all the way through the bearing by just using those bolts that I've got on the other side. And once I've done that, then I figured that the actual stator, it's not completely in its position. So then I sort of tweaked that and warmed this whole body up again, and then the stator went through with some pushing and yeah, with a firm hand. Once I did that, then I glued the encoded disc, as you can see there, on the main shaft, and after that I just put this end bearing in its place. So that's the end bearing in its place, and that's the encoder disc right there, which is a 1mm glass disc. Okay, I'm just going to cover this because I don't want anything to get onto the encoder. And then on this part I've attached the encoder read head. That's the encoder read head right there, and that's about it really. I did some modification, put a small chamfer around this, but yeah, nothing more has been done to this part apart from adding these 4 bolts to help us with removing this part. Originally I had a different way of removing it, but now I've sort of drilled and tapped 4 holes so it will remove this lid. So what this lid does is basically bringing the encoder read head where it needs to be, and also it will grip the stator and sandwich the stator between the body of the B-axis and this end cap or end lid, if you like, and then that bearing that you saw will sit inside this diameter. So I will glue the bearing inside this diameter, so I'll just apply a little bit of glue around here and then mount this where it needs to go, and then we are almost done. The last bit that I need to do is, this area is open, so that thermal paste is sort of oozing out a little bit, so I need to seal this, and in order to seal that I am going to use a gasket, which is a silicone gasket, and this is tough stuff. It's the temperature is that it works in, it's -54 to 371 degrees. It takes about, I think, about 24 hours to set, and then it's brilliant. So I'm going to seal that last bit that you saw with this stuff, and these are good for vibration, so this is vibration resistance. This is used in cars basically, so it's a gasket maker, and once it sets, then nothing will be leaking out, and that's about it. Then the B-axis is finally done. Well, thanks a lot for watching the video until the end, and it's been quite a challenging project, this one, and I hope that you have enjoyed this new version of content that I've tried. I must have recorded at least 14 to 15 hours worth of content, and managed to condense it into this 30 something minutes or so. Please leave a comment if you've got any questions. I will try to answer all questions that I see in the comment section. And if this project is something that you are interested in, please consider subscribing to the channel by hitting the big button that says subscribe. Since I have done shooting the video, I've done some other tests. One of them was to test the parallelism between the bottom face of the housing to the top face of the bearing. The results were mind-boggling. I've posted a quick video on LinkedIn about that one, and if you don't follow me on LinkedIn, please just type my name on LinkedIn and watch that video. It's quite interesting, that one. Next plans is to assemble the C-axis. If you want to see a similar content, again, please let me know in the comment section. And oh, one more thing that has happened. I've asked one of the engineers from the manufacturer of the direct drive motor to dial in remotely to a computer that I've got here, and they've been able to start the motor and even do a quick tuning of the motor. Obviously now it's without load. It will be retuned once we've got a load on it, which is the C-axis basically. But it is alive now, and it is working. There are some issues here and there, especially with cabling and some shielding. We've got a little bit of noise, but I will fix them, and hopefully in the next episode you can actually see the B-axis mounted on the machine and it is running. So that will be for the next episode, and thanks a ton for watching, and I hope to catch you in the next one. Cheers.